Okay, we're getting you ready for the communication number 4 test. It's got a lot of exponentials, logistics, that kind of stuff. And here is the first couple problems I want you to try. This one right here, would you agree that it is doubling? Okay, what type of growth is that? Exponential growth or exponential decay? Growth. And is it 10% growth, 100% growth, or 200% growth? 100% growth. Good. You could write this as 1 plus 1 to the x. And that might help you see 1 plus 1 is the same as 2. That's the growth part, 100% growth. All right, this one here is clearly not growth. What is that then? Decay. All right, what percent decay is it? And don't say 8% or even 0.8%. Those would be wrong. You could think of it as 1 minus what would get you 0.008? 992. So then the percent of decay is 99.2% decay. Get that? Okay. Next one. What is the starting value on this one? And starting value on this one? Not 3. Ha, I got some of you. How come it's not 3? Because of that 5 at the end. But the main point here is that you need to get that if it goes like this spot right here is not necessarily that point right there. Okay, that is the starting value right here, and it's where x equals 0. So I put in an x equals 0, and I can figure out what y must be. Because this part turns into what? The part I circled, what does that turn into? 1. So 3 times 1 is 3, plus 5 is 8. So that's how you figure out your starting value. The starting value is not always this number. In this case, it is that number. So what's the starting value? 29. And how about the growth or decay? Growth. What percent growth? 900% growth. Because this would be 1 plus 9. Yeah, move the decimal a couple of spots. 900% growth. All right, moving on. This one. Growth or decay? Decay. Why? That negative up there. So it's really 5 times 1/10 to the x. I got rid of the negative and I flipped it. Okay, so now, what percent decay? And then I said write it as 1 plus or 1 minus something. To the x, sorry. My x kept getting bigger and bigger there. 90% decay. Get that? All right. Next one. Got a couple points. Try to crank this one out. You should be good at these by now. It's exponential. It's not logistic because they didn't give you a limit to growth. Write me the equation for this puppy. I'm going to pause while you work on that. Okay, to make sure you did this one right, first of all, you go y equals a b to the x. And you know a, usually you can just plug it in right here. And if I'm going to be extra careful, because my grade's riding on it, I'd put in the point 0.0404 and see what happens. 4 equals a, b to the 0 is really 1, so yeah, a is 4. Cool. Okay, so now I can write y equals 4b to the x. And if you just do that right off the bat, you're right, usually, unless there's a number out here. Okay, so now I've got my beginning. Now I'm going to put in the other point, 2, 7. So 2 goes here, 7 goes here, 7 equals 4b squared, divide by 4, so it's 7/4 equals b squared. Got to take the square root of both sides. 1/2 power is the same thing. And hopefully you find yourself doing that. Raise your hand if you did. Okay, good. Then you were doing it right. Now you got the final answer, y equals 4, and what did b come out to be? 1 point what? 32? Okay. And then this is to the x, and there is my model. Raise your hand if you had that one right. Okay, good. That's something you got to know how to do. Moving on. This one, describe end behavior with limit notation. Would you agree that this one is growing? So you should be able to sketch it. That's the first step, is make a little sketch of what you kind of think it looks like. Then, write me the 2 limits. Go for it. Most kids are pretty good at this. Try to crank it out quick so we can move on. Zero comma 5 would be that spot. So left lim function x approaches negative infinity. That's where you go way to the left. It would be 0. Raise your hand if you had that one right. Okay, and the other side would be positive infinity, and it would equal positive infinity. Raise your hand if you had that one right. Okay, good. You're good at limits. Next thing, more advanced application question. All right, I changed these numbers around a little bit. It's similar to the one I gave you before, where there's birds, and there's all of a sudden less birds than there used to be. But they did a lot of this in the homework last night. I don't know if you noticed that. When would there be 1,000 birds? All you really need to do is find the equation for it. Let's say I found the equation is y equals 20,000, and this, I go through the big calculation to figure it out, and it's like 0.37 to the x. How do I finish this? Once I've got my equation like this, how do I put this in? Is that the x or is that the y? That's the y. Because x is time. X is like years. Okay, y is like the birds, so you put in 1,000 here, and then what do? You graph this, you graph that, and you see where they cross. Okay? So find your equation first. I've showed you how to do that a bazillion times. Then you take the number that they give you and either put it in x or y, and then you graph it. Let's actually do this one all the way, including the graphing part. So, right now, would you please start by changing this to be a 0, otherwise you'll screw the whole problem up. Remember? Starting value has to be a 0. Yes? Yep. And then the next one here, we adjust based on what it really is. The difference here is 5, so then this would be a 5. And now, go for it. See, I'll see if you did it right. If you get stuck, you can follow me. I'll be working at it slowly up here. Did you guys get 20,000 and then 0.525 to the x? Raise your hand if you had that equation. Awesome. We're on the same track. If you didn't, you could look at my work up here to see what happened. Then, just a quick check. Yeah, when will there be 1,000 birds? 1,000 goes here. The only way you have to solve this thing is your calculator's graph button. Because you don't know how to solve when there's an x in the exponent. There is a way, it's through logs. You're going to learn how to solve those things. Pretty complicated ones too. But for right now, we got to stick to graphing. Alright, so I didn't have a graphing calculator built into this thing. There we go. So that's one I'm going to use. Oh, cool. That is the same thing. Huh. I used it last hour, but I had slightly different numbers because we said 525 in here, and we said 0.53 in there, so I'll change mine to be 525. So I go 2, and then I got to insert a 5. Good. Enter. Graph. And you have to adjust your window so you can see up high enough, because you got to be able to see up to 20,000, or sorry, up to at least 1,000 where the line goes across. And then I go second, calculate the intersection, which is number 5. Hit enter, enter, enter. If there's only 2 lines, it's really simple. And there you go, 0.465. No, 4.65. So what did we just figure out? In the year 4.65, there will be 1,000 birds. What does that mean, though, in the real world? All right, because we start with 2030 was year 0. So this would be 2034.65. What does that mean? Well, it means that it's 0.65 into the year, which would be 65% of the way into the year. So you'd figure out 60, this is getting really complicated. They wouldn't ask you to, they'd just say in the year 2034, you'd be right. Okay? You could figure it out. You think I did it wrong? You think I did it wrong? Okay. Okay, yeah, it would be a little ridiculous to try to figure out 65% of the way into the year is what. It wouldn't be that hard. You can take 365 days, times it by 0.65, and you know how many days into the year it is. Anyway, all right, another kind. This is the harder kind. And I got to change something in here. I said it's 2, 100. I took yesterday's slide and then I just changed some of the numbers. There. Give that one a shot. See if you can handle this kind. If you don't know how, I'll show you in just a minute. So all I asked you to do here is to build an equation for this. Your first step is to figure out what A is. And A is not 90. All right, so you get this as 650 here? All right, good. And if A is not 90, well, wait a minute, what is this? If this is 90, it's 0, 90. Isn't that an X and a Y? Yeah. X is 0 and Y is 90. So I put in 0 and 90. And then I solve this thing. That'll tell me what A is. It won't tell me B because B cancels, because B to the 0 is just 1. It's just going to disappear. So it's going to read 90 equals 650 over 1 plus A. And then use your algebra skills to solve that. You could actually graph that on both sides. It would work. Anytime you want to solve an equation, graph both sides. Done. See where they cross. Yes, sir. You will need to memorize this general form of this equation. This black one here, got to memorize that. It's not given to you. All right, so who's got the answer? Is it like something 0.2? I can't remember exactly. 6.2, there we go. So A is 6.2. Do you need help on how to do that? You'd multiply both sides by 1 plus A. And then this would cancel this. And then I'd have 90 times 1 plus A. I'd divide both sides by 90. And then I would subtract 1, and you get 6.2. Okay, so I got A as 6.2. Now what? I rewrite it again. Y equals 650 over 1 plus, this time I know A, 6.2, times B, which I don't know, to the x. And now I use the other point to figure out B. Plug those in, figure out what B is. Some of you have probably already done it. Again, if you wanted to, you can graph it. Find B that way. Yep. Alright, so 100 equals 650. I don't want to rewrite that whole thing. I'll just start solving it. So how would I start? I would multiply both sides by the denominator. So I go 100 times the denominator. And if I multiply on both sides by that, on the right side it cancels. So I'd be left with just 650. Now I could multiply this in, but it'd probably be smarter to divide by 100 right now. 1 plus 6.2b squared. Here, I'll show you what I mean. If I divide this by 100 and divide this by 100, it'll solve faster. I did this wrong last hour. I thought it was 65. When you divide by 100, you move the decimal 2 spots, 6.5. And then I subtract 1 from both sides. And I got 6.2b squared equals 5.5. Divide by 6.2 on both sides. And I got b squared equals, I have no idea. What the heck is 5.5 divided by 6.2? Thank you. Anybody verify that? Thank you. Then square root, which is to the 1/2 power, 0.89 to the 1/2, which is 0.5 something if I remember right. Isn't it? Could be wrong. What do you have? 9.4. Sorry. You're right. Thinking of a different problem. I remember because I was like 89 only goes up to 94, which is kind of weird, but it's to the 1/2. It's a square root of it. Okay, so I now know A and B, so I can write it all out. Here is the final answer: 650 over 1 plus, and we knew that all at the beginning. And then we figured out A, which is 6.2. Then we figured out B, which is 0.94. That's to the x. Raise your hand if you're feeling confident on that kind of problem. Okay. And those of you that aren't, you have another one to practice on your homework, which is like that. And there's an answer key for it, of course. And if nothing else, you can console yourself in the fact that there's only going to be one problem like that on the test. Okay, so if there's one that stumps you, you can still get an A. You just have to not make any mistakes on the other ones. Okay, I'm hoping you can handle this, but if not, it's not the end of the world. All right, you know what that symbol means? It definitely gives you that danger feeling, and you're right, it's radioactive. And so that means that an old barrel with this on the side of it would be kind of scary because it's been sitting around and the radioactivity might start leaking out of it. They have that actually happening in places. We have a place called Prairie Island, the nuclear power plant, and they have these huge casks that store the spent waste. Now they're super safe, but all it would take is, you know, some crack in the side of this cask, and all of a sudden you get this radioactive stuff oozing out of it. So a lot of people are not real comfortable with having that stored on site there. But right now there's no place the U.S. government has to put it. They were going to try to build this place called Yucca Mountain. They were going to dig out a big hole in the side of it and store all of our nuclear waste from the whole country inside this mountain, which seemed like a good idea, except the people that lived near Yucca Mountain. And so anyway, right now they're still trying to figure out what to do with it. They don't really have a great plan. You want to make $1 bazillion? Figure out how to change nuclear waste into like just normal waste, because nobody knows how to do that yet. All right, 500 milligrams of radioactive isotope with a half-life of 100 days. There's a shortcut way to do this, and there's a long cut. I'm going to show you the long way first. I'm not going to like do it the whole way, but the long way would be to say at time 0, how much did I have? 500. Then at time what? 100 days, I would have 250 because it's half-life, it's going to be shrinking. Now I got my first point, my second point, I can do it just like that other problem. But those take forever. And there is a shortcut on this kind of problem that is awesome. If you remember the shortcut I showed you yesterday, try it. It starts y equals and the starting value, and see if you can do it. Okay, the starting value is 500, and then what is this doing? Doubling, tripling, halving. So what do I put in there? 0.5 to the x over 100. Get that? It's way faster than that other way. You can still get an equation that would work the same way. All right, let's do another one like this. This is fresh news. This, not this baby, but there was a 13-pound baby born yesterday in Iowa. That makes news because normally babies aren't anywhere near that big. In fact, it was only 0.5% of all births, not half, but 0.5%. Half of 1% of all births are that big. And then they usually are C-sections, as in they cut the mom, take the baby out because it's too big. But this one was natural birth. So she got that baby out. Anyway, so it turns out it's a mutant baby, and it doubles in size every 40 days. Would you please figure out an equation for me on that one? Just for perspective, I was always shocked as a father that after about a week, what you hope is that your baby is back to its birth weight. Isn't that weird? Because after the baby's born, it actually loses weight for the first few days, and then hopefully starts gaining it back. So after about a week, all you are is back at the same weight you were before. So, okay, so y equals 13 doubling x over 40. Raise your hand if you had that one right. Okay, good. So you got some easy points that you'll be able to get to. There is no need to show me any more work than that. When it's that kind of a problem, it's that easy. Okay, this one. You'd have to tell me what order, otherwise you'll get it wrong. If you just say you do these three things, you get it wrong. But you got to tell me, well, if first you do this, and then you do this, and then you do that. Okay? There's 3 steps. See if you can tell me what the 3 steps are to turn this into that. All right, hopefully you're thinking that, okay, that's really the same as negative 2x plus 5. That's the way we usually see them. And then that 5 is the first thing you would do, because normally you'd do the multiply first, but since this is inside, you do the opposite of normal. So you should have done the 5 first, left 5. Raise your hand if you started with left 5. Okay. The stuff that's up here is the stuff that's by the x, and that's the stuff that's inside. If there had been like a plus 5, that would be on the outside. Okay? So every function is different about where it's all based on where the x is, though. So like in this kind of function, remember the fraction function? It was like this. The inside was down here because it was by the x. So if it was like that, it would have been 2 to the right on that function. All right, so that's on the inside. So we do the opposite of normal order. So normal would be multiply, so we do the plus 5 first. The next thing is, there's 2 things here, a negative and a 2. In gymnastics, you'd want to stretch before you flip, right? So that's normal order. So we don't stretch before we flip before we stretch. And actually, this isn't a stretch, or if you wanted to say a stretch, it's a stretch of 1/2. A better way to say it is it's a shrink factor 2. And it's a horizontal shrink, even more than that, factor 2. Or you could say it's 2 times wider. Or you could, narrower, sorry. Or you could say it's half as wide. But the point is it's got smaller. then the flip is a left-right flip. You could say horizontal, you could say left-right, and you could say over the y-axis. So that would be a good way to say it. Oh, you're over y. Sir. Yep. Yep, you got to do it in the right order. And normal order has these going first, so they can't be first. It's got to be that first. Because it's on the inside, you got to do the opposite of normal order. It does make a difference. The only thing, I don't even want to say it. There's another way you could do it, but I don't want you to. Just stick with, then what you said was not it. I don't want to add any complication to it. So just stick to what's normal order, do the opposite of that. Yes, sir. No, the stuff on the outside is normal order. So let's say we had x plus 3 squared plus 17 and a negative there. So the stuff on the inside can go first or last, but whatever you do on the inside has to go in opposite of normal order. The stuff on the outside is in normal order. So this one, you could start with left 3, and then go on to the outside where normal is multiply before you add. So that should be first, so it should be your flip next over x. It's an up-down flip. And then that should be your up 17. Opposite way also is okay. You could start on the outside. Starting on the outside, again, you do it in normal order. You would do that first, which would be the flip over x. Second thing you could do is this, which is up 17, and then the last thing you could do, if you're going to start on the outside and then go to the inside, the last thing you do is the inside, which would be left 3. Any questions about those? That's doing things in the right order. That's from last semester. So, all right, and that's it. We made it to the end. So, got a worksheet. It's right here. I'm going to strongly encourage you to check it tonight. Mrs. Richards already has posted it, so there's no chance of it not getting posted. And just study. We've done a lot of practice. I think you'll be fine. This one's definitely a doable test. I looked it over, and I think there'll be lots of A's and B's.